Hi, in this lecture, we'll be discussing about some technique to identify the optimal number of clusters given a data set. So if you recall, we have been discussing about different clustering algorithms, K-means, the hierarchical cluster, Gaussian mixture model or DB-scan. Today, we'll be mainly focusing on how to identify the optimal number of clusters, okay? So let's start with a simple scenario. So here we are given some data points. We can clearly see that it looks that there are three clusters that define this data set well. So what if we have only one cluster? Okay, so this will be looking like this. If you think that the data should be in two clusters, you might have a configuration like this. And if three clusters, then the configuration should look like this. You can grow to four cluster, but the question is that which one is the most appropriate one: 4, 3, 2, and 1. You can quickly see through your visual interpretation that it most likely three cluster configuration is the best configuration. But the whole point is that how do we identify that the three cluster is the best cluster? So that will be the main topic today. So there are two popular methods, one what we call elbow method and the other one is silhouette based method. Okay. Try to understand about the elbow method. So the main criteria here or the main metric here is the explained variance. As you can see that the x-axis is actually representing the number of clusters. Even you cluster your data into two groups, you were able to explain the variance of the data 40%. If you increase to three clusters, you are able to explain your data up to 60%. So as you can see that as you create more clusters, you are able to more explain the original data. So you have to stop at a point where increasing an additional cluster doesn't actually improve your variance accumulation. So in summary, we can see that it's a kind of upside down elbow. So we have to stop at a point where adding an additional cluster doesn't help the configuration to improve in terms of variance explanation. So that's the whole idea. The other method, what we call silhouette score based method. So here the silhouette score is actually the mean or average of the silhouette coefficient. So what do we mean by silhouette coefficient? And silhouette coefficient is actually per data item in your data set. Okay, so silhouette coefficient is b minus a divided by max a b. Okay, what do we mean by that? Let's imagine that xi is a data point within cluster ci. So what is the average distance between this data point and the other data points within the cluster? Okay, so that's the a. So average of the within cluster distance. And b is, here we have a three cluster configuration and we are talking about a data point that is within a cluster ci or within the blue cluster. So you have to find that what is the closest cluster. So in this particular case, the CJ cluster is the closest one. So we have to actually estimate this distance between xi and all the xj's, not in the red cluster, because red cluster is actually not the closest one. So that is B. So for each data point, you estimate its corresponding silhouette coefficient and then you take the average. So that will be your silhouette score. So now I go to the notebook. So here, so this code had been adapted from a source that we have referenced here, and we are using a data set what you call customer wholesales data, and you can see the corresponding features. So just like other modeling steps, we need to encode our features. For the categorical features, we used one-hot encoding, and also we need to do our data scaling, because at the end of the day, even if we are doing k-means, we need to make sure that our data are scaled. Okay, So after all the pre-processing done, the data is of SAFE 440 records and 11 features. And here we are actually tracking two scores or two matrices. One is sum of squared distances and silhouette score. So this is actually equivalent to the explained variance metric that we have shown in the PowerPoint presentation, but you will quickly see that there is a relationship between this guy and the explained variance. Okay. So we are using k-means clustering algorithm, and we are checking for number of clusters 2 to 15. Okay. So let's run this. And here, if when we plot the sum of square distances, we found that the data follows this pattern. So how we are reading? So if you have two clusters, then your sum of square distance will be over 200. But as you move to three clusters, you have between 100 and 150. As you progress, you can see that when you reach to cluster 6, your error is the closest to the minimum, and as you move forward from 6 to 7, 8, 9, we don't gain anything. So you can clearly see that this follows our elbow pattern, and the idea is that you have to choose a point down this region. So for our case, we can either choose 5, cluster 5, or 6, or 4. Here we are showing the silhouette score, and again for the silhouette score we can see that from cluster 2 to cluster 6 the silhouette score is actually increasing. So that means that we are separating the clusters well. So again you can see that even using silhouette score, the solution looks to be a number of 6 clusters actually explain this data well. Okay, but you can choose any point around this area, 6 or 5. Okay. So these are the main idea of silhouette score and elbow methods. I will be sharing this notebook and the PowerPoint presentation, so you can double check with things. Okay.